All right. So today is week 4. We're officially over halfway through the class. It always feels like it goes faster than I expect it to. Um, this week we'll be looking at a couple different tools, mostly notebooks that other people have made. So uh, I try to document some of the good ones that we'll go through, but some of the other ones I've linked to might not be as well documented. Um, if you do run into issues, just drop notes in the Slack channel or attend one of the co-working sessions, and I'll try to get to that. And if there are issues, I can try to update the notebooks and add things to them. I tried most of them, so they did work fairly well. So fingers crossed that other people don't run into issues, but we might. We'll see. I'm going to go ahead and share my screen, and I'll also share the link for today's slides. Well, actually, before I start going into slides, does anyone have anything they want to share from this week that they made? No? I feel like this week was a little quiet for everybody just because we had the extra like long weekend, at least here in the US. I did notice at dusk, I think you posted in the Slack channel some of your experiments with the circular loop, which I don't think I really covered much last week, but I do think it's worth pointing out that there are two or three sort of self-looping model or like interpolation methods in that sort of big, huge notebook that I have with has everything in it. There's the noise loop, which I think we talked very briefly about last week, which does, as you might expect, have some noise to it. So it means some of the speed and some of the ways in which it moves can feel a little bit jerky, whereas the circular loop is a little bit smoother. In an ideal world, it would be perfectly smooth, but it sort of turns out that none of our latent spaces are really like perfectly smooth. So even then, it feels there can be little moments of speed changes, that sort of thing, but I do think it's much better than the noise loop, or also much better than picking seeds individually. The downside is you don't have as much control, right? Like you can't really set a lot of those points. You just sort of like randomly generate a handful of them and see what you like most, that sort of thing. So if you didn't get to play with those, I definitely recommend them because they are kind of nice because they just loop by default. So it's a nice way to get some looping video if you need that.
I have a question.
Yeah, go for it.
Um, I think there's a slurp. Is that the other one? Like it was.
Yeah.
So I feel like that's kind of a new addition, or like a newish addition. So what's the difference between like what makes that like special or like different from other ones?
Yeah, so when we start talking about slurp, let me see if I can find a graphic that will sort of elucidate this. Um, so one of the things is that we have to remember that our latent space is more than 3 dimensions, which means um, it's what we refer to as high dimensional. And what mathematicians have sort of found out is that in high dimensional spaces, things don't operate the way that our brains think they do, meaning that like what we think as a linear interpolation is not actually like a good distribution of the space. I'm trying to see. I at one point had a good article that sort of explained some of this, but I think this is a good. Let me just show this example as a graphic. Let me share my screen here real quick. So if you look at this graphic here, one of the things to think about is when we talk about high dimensional spaces, the way we've represented them so far is in a cube. Um, but realistically, a high dimensional space is more spherical than it is cubical. So what that means is, excuse me, um, most of the good distribution uh, is actually like along a sphere. So when you're trying to find the best sort of seeds to distribute or like to move between, you actually want to do something that's more moving along a sphere rather than doing a linear interpolation. So um, it's been discussed that what you really want to do when, especially in the Z space, is you want to use slurp, which actually moves in a spherical pattern rather than in a linear pattern, right? So if you think about 2 points in space, you don't really want to move in a linear movement between those. You actually want to move in a spherical movement. So that's what slurp does. The creators of StyleGAN have actually said that slurp isn't really as important if you're moving in the W space because of the way that the W space mapping works is linear and slurping are almost the same thing. So I've left slurp in there because I think it's just worth seeing. There's also been a ton of discussion within the GAN community about like, should you do slurp or should you lerp between Z space or like just these points? So I added it just so people could see it. Um, I'll be honest, I don't see a huge difference between them. Um, but you might see a little bit of a better difference in your Z. Your Z might be less entangled if you do slurp, basically. Or it might just feel smoother. Also, I think what's often happens is if you choose between 2 points, your middle point might feel really muddy. What they describe as like just muddy. It just doesn't look like much. Whereas with a slurp, hopefully you get a better sort of like the ideal of like every image being good along that path is essentially what happens there. So I would generally say like my recommendation is just to usually do stuff in W space unless you like that entangled look. I think W spaces in general you're a better option. Um, and based on my own experience and what the StyleGAN people have said, like doing linear interpolation in W is fine.
Thank you.
Yeah, of course. Any other questions or thoughts based on sort of the interpolation notebook? Okay. Um, well, again, I'm happy to help people through co-working stuff, or if you're just trying to generate some things, we can try some stuff. This week we'll also be looking at, I don't know, maybe sort of an alternative to feature vectors, using stuff like clips. So we can try and see how those two compare with each other in this class. So let me just share the slides for this. Oh, I already shared them. I'll share them again just in case. And I think obviously like I sort of just move through every week as a new thing in this class, and I recognize that sometimes people will have busy weeks or a 4-day weekend and they just like will fall a little bit behind, and that's totally fine. Like I don't expect work every week. I also think like you should feel like if you really are enjoying a certain process, like just dive in a little bit deeper and like explore that more. Um, I would also gather some of you have already done a lot of interpolation work and you're just sort of like, I'm waiting for the next cool stuff to work on. So that's totally fine. But I definitely would recommend, trying to do at least one or two things every week, just because that's going to help. What I find is most important with a lot of this stuff is just like getting in the rhythm of doing it. Because when you have downtimes or times where you don't work on stuff, coming back to it can feel a little bit harder just because you're like, oh wait, what was this? What's this setting? What's this setting? So I find like a lot of this is just about getting in the groove of doing stuff and trying things. So um, you know, I'll say like you will learn far more by trying it and failing than you will learn by just like sitting here watching me do stuff. So if you need that extra motivation, I'm happy to push you a little bit. So all right. And as a reminder, we do have the co-working sessions. So those are Saturdays and Mondays. Um, Saturday of this weekend was like really hopping. It was pretty busy, which is great. I think we had a lot of good conversations that were not just about this, just about this class, but also about like how do you get people to commission you to do this work, like that sort of thing. So again, like these are totally open. If you have questions about how do I get paid to do this work, or like where do I find people, or how do I talk about it, like I'm always happy to have those discussions with people. Monday was pretty chill, I think, just because it was a holiday here in the U.S. Yes, and Bug is here. Um, the other cat got a haircut, and this one thinks there's a new cat in the house. Like she like doesn't even notice it, so she's freaking out today. So she needs a little comfort hug, which we all need every now and then. um, so yeah, so co-working sessions. I would definitely say like you should at least come to a couple of them because they're fun and they're ways to just sort of like talk with people and see what other people are working on. So if you can, please do. No requirement, but I think they are kind of fun and a nice opportunity to just sort of like discuss sort of the entire I don't know, the whole ecosystem of this stuff. And everyone here is in the Slack channel, correct? Okay, because I had someone else maybe from a different class was like, hey, I'm not on the Slack channel. I was like, oh man, we should set that up first the first week of class. So if you aren't, I do post lots of like little updates and things in there. I think this week I posted a link to a video on how to generate rectangular images from your square models, which is just like a nice update and maybe something that people will be interested in using. I think I linked to a video in the Slack channel if you want to check that out. Okay, so this week we're going to look at both projection and style clip, or I guess using clip with StyleGAN. The reason I think that we can combine these two is they kind of use similar processes. They use a thing called loss, and we'll talk a little bit about losses and how they work and some of the ways to work with them this week. But essentially, both projection and clip use these losses. They use a different way of computing the loss, but they use these losses to guide our vector space, or like guide our image in a certain direction. So projection will use an image as a target, and clip will use a piece of text. And you probably could combine the two. I don't have that in these materials, but I know one of the projection models we'll look at will actually let us do both. So maybe like if you're interested in trying that, maybe you want to try that and see how that works. So let's talk a little bit about how projection works. If you haven't seen projection before, projection is essentially the process of taking an image that exists outside of your model and finding the closest representation of it in your model. So you can imagine, like you probably have seen this before, but people are trying to find Hillary Clinton or Barack Obama inside of FFHQ. I don't think either of those celebrities exist within FFHQ as a data set or even as a model. So the process of which we find that is through a process called loss. What happens is you compute the difference between those two images using a pre-trained computer vision model called VGG. You get a loss score back from that. So basically what you do is you say, hey, here's an image I want to use or I want to find in my latent space. What the model then does is it either picks a random point or a predefined point, which is again a vector in the latent space, and it computes the loss between those two images, right? So it generates an image from StyleGAN, and it says, how different is this from a portrait of Barack Obama? And we get a loss score back, and that last score sort of says like, hey, I think you're this far away or like this different from what you need to be inside the vector space. The projector then takes a leap or a step or an iteration that moves toward what the loss is saying is the score that it needs to move to. And then it does that over and over and over again until hopefully it ends up in a place that looks something like the image we've given it. And this is what's called iterations. So one of the biggest things to think about is how many iterations do you want to use? Iterations take a certain amount of time. Usually it's only a second or two, but with 1,000 iterations, that can add up to 10 minutes or whatever. So it's important to think about like, how many iterations do you want to have? What's the right mount? That sort of thing. So here's a really quick example of something that I've done, which is just taking a photo of Harrison Ford from Blade Runner and trying to find this in the latent space. So one thing you'll notice here, let's pause here real quick, is at the very beginning, we are looking for a person, right? So it starts, this particular example starts at with what is called the most average person in FFHQ. This person will show up quite often. This is, I would assume like 0, 0, 0, 0, 0 for all 512 vectors. So this is where we're starting. And then as it animates, you'll see it's like moving closer and closer to the right image. Now, one of the things you'll also notice is it doesn't move linearly, right? It's not moving like every step is perfectly like a better solution to the previous one. So there's like a randomization, almost like a random walk that this thing goes on. And as it goes on this walk, it learns sort of like, oh, over here is a better score, over here is a worse score, so keep moving in this direction. And I believe, I don't know how many iterations this is, probably a couple thousand iterations. So the longer you train it for, or the longer you run these iteration processes for, hopefully the better the model gets. But you'll notice that, very early on, you see this huge leap. And then as you get closer and closer to where you need to be, it's doing a lot of work to like try to find that right space. Often you'll find that it feels like it's going in a circle forever. And then like, at some point it like sort of kicks out of that circle and it finds, something that looks closer and closer. And then it starts to like, as it gets really, really close, it starts to feel like it's just doing this little bit of a jitter thing. Yeah, it's a good point. Harrison Ford's Fiverr equivalent, yes. So, where we end up is here. Now you could say like, this isn't really like it clearly doesn't look like Harrison Ford, right? Um, but what is interesting is that, it got a lot of detail like rather correct, right? It sort of gets the hairline correct. It gets the face position fairly well. Um, it will these models are sort of like they'll never really be perfect. You could even put in an image from your data set. Like we could actually take an image from FFHQ, run it through this process, and we'll still pretty much never find that example of the person in a data set, right? Because the way this model works, you can think about StyleGAN models as almost a compression model, right? They're taking a huge amount of data and compressing it, and they're trying to find the best representation, but it's never going to be super accurate or like perfectly accurate. So that's just a thing to know about is like, this will never be a perfect process. If you were to put Barack Obama in here, you might get a better result, or like you might get something that looks more like Barack Obama versus Harrison Ford. Each iteration, if I were to run this again, I might get a slightly different result just based on that random walk path that things go on. So this is kind of a like hit or miss process. There are some things you can do that are important, like that are worth sort of considering as you do this. One thing I'd probably note here is that you might notice my eyes aren't perfectly aligned, right? My eyes are on a little bit of a slant. So if I were to do this over again, I would actually run this through that face detection algorithm that straightens everything. So that's a really important thing to think about is that how your model or how your data is set up, you probably want to set up your projection image in the same way. So if there's alignment involved, you should probably want to align that in the exact same way, unless you're trying to do something weird. Speaking of something weird, I think Grant might have mentioned this previously. This is finding Mario in FHQ.
I would
And so,
not wish this horror upon anybody because it's nothing to do with me.
okay, I will take,
That's
I will take,
upsetting.
I will take credit. Was that you? Okay. So, okay, so it's gotten pretty creepy now, but we've gotten really close to this example. And one thing I'll note here is that AK92501, who if you don't follow on Twitter, I highly recommend. They post to a lot of really cool links. But I think this model actually was aligned. The data was aligned. It's like, so the eyes are straight, the chin is in approximately the right place, et cetera, et cetera. This has also been run for quite a while. But even the mustache appears, right? So like, um, Mario cries black ooze, yes. So again, you can also find really weird stuff in your model, like stuff that you don't think would exist in a model like this. And this is kind of the fun thing of StyleGAN is that you can think about it almost like if you have to learn a language and then you're like quizzed on learning that language, you probably learned a bunch of other stuff that wasn't a part of that quiz, but you still learned it. So you know more than you realize. And that's sort of what we're finding with these StyleGAN models. There's lots of stuff sort of hidden in the corners of them that allow you to do various things. So these are actually both two fairly older projection versions. There's now been a lot more work sort of done on creating better projectors or creating new projectors, and we'll look at one of those today. So I also want to step back 1 second and just talk about learning rate. So as I mentioned here, you've got sort of this step process, right, where you're stepping in a certain direction. One thing that's really important with projection is how big is that step? So that's determined by what's called the learning rate. The learning rate is, how big of a jump do I make each step, right? So if you were to take a big step, initially your model might start to look better. But then as you get closer and closer to where you want to be, your step might be too big that it's overstepping where you want to be actually be. So this is an example of maybe where a learning rate is too high. And the flip side, your learning rate could be too small if all you're doing are a bunch of tiny little iterations, and all you're really doing is sort of staying where you already were and just making like minor little updates. There's also a thing within these high dimensional spaces that are called local minimas. You can think about these as almost like little peaks and valleys. And the goal of these optimizers is to end up in a valley, but to end up in the best valley possible. But if you're only moving around little spaces, like a little corner, you can end up in what's called a local minima, which is just like you're stuck in a place and you can't get out of it, almost like it's quicksand. So this is a case of where like you have too small of a learning rate. So one of the things you'll want to do as you play with this is like, what's the optimum learning rate? And there's some defaults that all these models come with, and you'll want to play with either increasing them or decreasing them. Also, if you want to make weird stuff, like increasing them will usually lead to more weird stuff. So if that's something you're interested in, you might want to try that too. There's also a pretty common technique, which you might have guessed by now, which is like, well, why don't you do both, right? Why don't you start by making big leaps, and then as you get further and further along, you make smaller leaps. So this is a common technique I think we'll see in at least a model or one or two notebooks, where they're actually doing what's called learning rate decay, which means over time your learning rate gets smaller and smaller and smaller. So this is a sort of like, you can do this with anything, or like with any loss. There are a bunch of loss options here, right? So the idea is that there's a scoring system, and somehow you're getting a score. And how do you get a score? Well, there could be a couple different things, right? You could compare both images and use a model like VGG16, which is just like a really like old school but sturdy way to sort of compare two images and see how different they are, right? This is almost the LPIPS model we looked at. LPIPS actually uses VGG as well with a little bit of extra stuff. But essentially, VGG is just a way to compare two images. So if you compare two images and you get a score back, you can then take that and give it to the model and say, like, here's the score you got, update like where you're going and how you're updating it. So we'll look at VGG today, which is just like what the default projector uses. And then we'll, in that latter half of class, we'll look at clip. And clip we've also looked at before, which is a way to get scoring back from a text. So basically you give it a piece of text and an image, and it says, here's the score, how different these two are from each other. There's a bunch of additional metrics you can use, and we'll look at some of these when we look at the sort of cooler projector. There are ways to do pixel loss. So maybe you actually want to look at every individual pixel in your image and compare the two. There are also things like penalties, where if you're really far off, you want to penalize that either more or less. And if you're really close, you want to penalize that more or less. So you can almost think about this, again, like learning, right? Like, how do you grade a student's paper? You know, did they get half credit for something, or is there no half credit and they just get a wrong answer? Like that's sort of how you could think about a distance penalty, right? If they got close, you might say like, okay, 3/4 of credit. But if they're really far away, you're just like, no, you just no credit whatsoever for that answer. So there's a bunch of techniques, and this is sort of like, this is about half of what like research into these areas is what's the best scoring system? How do we like interpret that and use that to make better images? So we'll look at some examples of that today. So some things to consider when you're doing projection, because I see a lot of people who are just like, they'll just stick an image into their model, and then they'll get an image out and they'll be like, this doesn't look very good. What did I do wrong? So here's a couple of things that I am like would encourage you to play with whenever you do projection or whenever you do one of these loss guidance tools. So I mentioned this before, but if your data set was aligned in a certain way, make sure your input image is also aligned. Because if, again, the model has learned a certain configuration of images. It's learned that eyes always go here. If you feed it an image where your eyes are in the upper right corner, it's not going to know as much about how to actually like change those. So make sure that if you are using an aligned data set, that you go ahead and also align your target image. I also mentioned this before, but play with the learning rate. You can sort of find out what works and what doesn't. Also, we'll talk about producing videos from these. I find that learning rate also helps me understand both the iteration count as well as like learning rate through a video. So you can sort of watch it animate. You can sort of say like, oh, it's just moving too slow from the beginning, so maybe I just need to use a higher learning rate. Or it feels like it's getting stuck somewhere. Why don't I try a higher learning rate? Or it just feels like it's erratic, just bouncing around. Maybe I should lower my learning rate. Loss metrics, so we'll go through this. I definitely recommend that, especially for the Peter Bailey's projector, which is what we're going to look at. There's a ton of different metrics you can use. And I would probably say like on a per model basis, you might find different ones work better. So I'll show you some examples and comparison methods between those. And then lastly, it's always good to run your projector a couple times just to see like like if you really want to get the best Harrison Ford version, you probably want to run it a couple times and pick from the best because there is some randomness built into this. So if you run it once and you're like, I didn't get a good image, if you run it again, you might get a better image. Also as you update and play with these other things, it's kind of important to know, what's working better, what isn't. But even when you like feel like you've got the right optimum settings, it's still good to run it a couple times because you will get different results each time. One last note is if you've been in a previous class with me, you know that I've said you have to size your image to the exact same size of the model. So if you have a 1024 by 1024 model, your input image has to also be that size. They've now fixed that. So now basically if you give it a rectangular model, it's just going to crop it or if you get a rectangular image, it's just going to crop it and resize it to the dimensions that you have in your model. One downside of that is that it might crop it in a way you don't expect. So I would probably still recommend that, again, you probably want to feed an image that is as close to your model data as possible. So if you have a rectangular image, you might want to crop it to square and align it correctly and resize it, using whatever methods you have. So if you feed a really small image, like 48 by 48 into a 1024 by 1024 model, it's going to do some weird stuff because it's just going to upscale that thing like crazy, which actually would maybe be cool. I don't know, maybe you should look at that. But just know that like you do want to make your target image as close to your model data as possible. Any questions?
I have one.
Yeah.
So like you talked about like running it multiple times and like getting different results. And like it occurs to me that like the whole like local minima kind of thing is probably happening just to a lesser extent, where it's like, I don't know, I guess the way I'd approach it is like, let's try to sample like a bunch of spots in the latent space and then move from the best one. But I guess, I don't know, is that just too intensive to like do? Or I don't know.
No, that's actually a technique that we'll see later today, which is like, where do you start? Like, right, what's your
Okay.
starting point? So a lot of times what people will do is they'll take a distribution and they'll figure out what the best starting point is by like, using that. The downside of best starting point is even with the best starting point, if your learning rate is too high, you might just like jump over where you need to be, right? So it's like there's still a lot of like randomness at play here. And I think it's definitely a good idea to start thinking about like how can I optimize for this? But there's still some imperfections even in that process. But yeah, I think like that's a good idea. Another thing that I've seen people do is you could run this a handful of times and remember that your output, even though it's an image as we look at it, is really a vector, right? So you could run it multiple times, get maybe 10 different vectors. You could average those vectors together. And that would give you sort of like a averaged position of all these spaces. Is that going to be better? It's hard to say. But again, there's lots of techniques that people are doing to sort of like optimize for these spaces based on that. So definitely I would like start thinking about more and more like, hey, what if you did this or what if you did this? Chances are someone's done it, but we should still look at it. And there's a bunch of methods. We'll look at the Peter Bailey's one, and there's so many methods that he started to add in to sort of let you sort of like do that without having to know how to do that in PyTorch or whatever. So there's lots of options here. Other questions? Cool. Okay. So we'll go through the notebook in just a minute, but I want to show some examples of what this looks like. So whenever I refer to the basic projector, that's the projector that comes default with StyleGAN. And honestly, it's probably not really worth using unless you have an image and a data set that is exactly like very similar, right? So FHQ. I've got a face here, I've aligned the image, and I've got like, I'm going to project it into FHQ. This is an example of me finding a very sort of, I guess conceptually it looks similar to my model, right? So this is a black and white, or this is a grayscale model with like colorful flowers in it. sorry, black background with colorful flowers. So I found this image on the internet and I was like, oh, this is pretty similar. I wonder what would happen if I like projected this into here. So when I projected this into here using 1,000 iterations, you'll see this does not look good, right? This doesn't look anything like this, but you can see what it's trying to do, right? You'll see this purple splotch here is sort of being represented here. And then I've got a green splotch here and it's sort of coloring my code here, or like my images here. Again, pink, more green, maybe some orangish colors. So you can see what it's trying to do. Now I only ran this for 1,000 iterations. I could try to like crank this up to 10,000. That would probably take like 30 minutes to run, but I could do it and I could see if that gets me to a better place, right? The basic projector literally just uses VGG and it just says, here's an image, give me a score. And the problem with this is that basically my model like doesn't have any images that look like this. So it's gonna be really hard to like sort of force the model to find something that looks like this. Now you might say like, well, it found Mario, but again, remember that Mario, even as like a basic structure, is much more aligned to FHQ than this is. So that's the challenge with some of this stuff is like, even though you think, well, like it found Mario, so clearly it must be able to find weird stuff in my model too. It can depend a lot on just like exactly what data you're using. So this is the basic projector. I recommend using it and just seeing what you get, but I think you'll very quickly want to move on to the Peter Bailey's projector, which I have many, many examples of. He has a ton of options in here. So I've sort of started just to list like on the left-hand side here what the options are. So already you can see this is the exact same model, just using a different projector. You can already see how much closer this image is to this, right? Now, you might also say like, well, this is super noisy, and like this is still like a smooth looking image, so what's better? Again, artistic intent, I can't really say, but you can already see that like this is already doing a bunch of stuff. So let's talk about a couple of the things that he's got available here. So this is, oh my God, Bug, you're killing me today. Come on, baby. All right, he's got a setting for learning rate. So the default projector, you could probably dig into the code and actually edit the learning rate there, but there's no sort of surfaced way to edit the learning rate. But Peter's version allows you to access the learning rate. I used his default of 0.1. That's much higher than I found a lot of models use learning rates as, but I guess it works. So I had pretty good results with this, but you could play with raising this, lowering this. Next is there is a pixel loss. I believe what pixel loss does is it actually looks at pixel per pixel and calculates the loss score based on that, right? Which makes sense because if we look at this version, my model is drastically different than the image I'm giving it. So it probably helps if I actually get a pixel score as well. That seems like that would help much more. Penalty, so there's some sort of form of penalty. I don't actually know exactly what it is. I could probably dig in and find it. But I would assume he's penalizing farther scores, like more like where areas where the input and the generated image are very different. He's probably penalizing that more. And that would hopefully like move the model quicker into certain areas. And last, there's a thing called center. Center is what happens there is he's taking a second crop of this image. So he's cropping in closer and he's using that as a score as well. So he's actually like sort of got two different image scores going on. Why would you do that? In the case of FFHQ, you might want to crop into the face a little bit more and actually get more of the face details, right? So in that sense, it makes more sense. For my model, it doesn't really make sense. So the next step that I did after seeing this was I said, okay, this is starting to look good. What would I do to change this? Well, I could change the learning rate, but I don't really have a good sense of whether the learning rate needs to go up or down. I could try turning off one of these penalties or these like sort of loss scores. And that's what I did. I turned off the centering score because I know how centering works. And I sort of said, you know, I feel like cropping into the center of this image isn't really going to do anything additional for me. So here's what that image looks like when you turn centering off. I would personally say like this looks better to me. You get a little bit more definition in the shape. You get a little bit more of the coloration. Now what's funny here is you can still see sort of my model underlining all this, right? You can still see the branches, the flowers, that sort of thing. So it's not perfect. I don't think this will ever be perfect because this is such a different image. But already we're getting closer. And so I definitely recommend, like, depending on what your model is, you might want to turn centering off. So this is actually about as close as I got. I looked at turning both these other two off, And based on what I have here, oh God, turning these off doesn't really make a lot of sense. We can look and see what they do. So the first thing I did was I turned off pixel scores, and already you can see a huge drop off, right? And that's again because my model really mostly wants black backgrounds. So without saying on an individual pixel level, like what should I do, it goes mostly to black. And then when I turned off the penalty score, it really didn't do that much. I think what it looks like the penalty score does, it sort of keeps maybe the structure of my model a little bit closer. So it looks like the penalty score being included actually like sort of shifts maybe the projected image a little bit more. I didn't play with the learning rate at all. I definitely would recommend maybe doing that and seeing what you get with your own model. I would also maybe play with iteration count. So you could increase this, you could lower this. I found that with a really different image like this, you probably want to increase the iteration count more than decrease it. Because of that process of sort of moving in the right space, the longer time you give these iterations, the more it can sort of do these loss scores and actually improve the image. Now, it's diminishing returns. If you were to set this to 50,000 and let it run for like a couple hours, it's probably not going to do much post, iteration 10,000 or something. So there is sort of like, I wouldn't like crank it up too high. And lastly, I also want to say so we'll look at how this uses a seed value for our random position. There is a k-means clustering system within this, but I didn't use it, which means you can set a seed value. So again, we talked about seeds last week. Those are placeholders for vectors. And you can kind of see so here I've set 10 and 10. So I ran this one twice. And you'll kind of see that there are definitely some sort of lines through this model that kind of show that it's using the same one. But you'll see even running this twice, you get slightly different results, right? You get slightly different textures, that sort of thing. When I change the seed entirely, again, these all look fairly similar to each other. But if you look up close, you will actually see that the detail in this one is pretty different. There's a lot of different sort of texturing and that sort of thing. So I wouldn't say that a seed is going to dramatically change the outcome of your model, but it might give you different textures you like or don't like. So again, this is all sort of like little details here and there that you might want to play with and sort of see what happens. And lastly, before we dive into the notebook, I do want to mention that projections are just W spaces vectors essentially. So when you're done, you will get a vector back. It's usually going to be a format of .npz file, which you'll have to read into. I'll show you how to use that, but you can actually do interpolations with these projected images. So this is an example of me. I made some of these images using some pretty similar techniques to what I've just shown here. And then you get a bunch of vectors, and I did a linear interpolation between all those vectors. So that's what this process is. If you're familiar with David Rudnick's work, these are some of his images that I projected into this data set or this model, and then I animated from. So you get you can sort of see where the model actually stands out, right? There's lots of moments where there's stuff that looks more like my model, but then it sort of interpolates between these other things. So this is, once you've done projection, this is actually fairly easy to do. What you'll do is you'll just combine, there's a script to just combine all of your NPZ files into one, and then you can use that as a interpolation.
Question.
Yeah.
Are there different types of interpolation for this, or is it just one?
So this works just like linear interpolation, where basically every one of these files has a seed, or not really a seed, but it's got a W vector. So you're going from W vector to W vector to W vector. So I don't think slurp works in W, just again, because W doesn't really need it. But you can use stuff like easing. I think these use an easing method or other things to sort of change the speed at which these work. And there's probably more that we could do if we felt like it. Any questions before we dive into the notebook? Okay, cool. Let's go ahead and do that then. So this is in my massive sort of kitchen sink notebook. So I will just make a note that this is a good notebook to use the table of contents with. All the way down here at the bottom is a thing called projection. So first thing, I'm just going to get this up and running. I'm going to skip singing to drive because I don't need to. I'm just going to use gdown to get my pickle file down. But if you want to, go for it. So we'll go ahead and run this. One thing to note is, I think I mentioned this in Slack earlier this week. If you are using any of these newish tools and you haven't updated your repo in the past week or two, you probably want to run this cell, which is going to update with all of the latest code. Otherwise, you might get some error messages, so make sure you run this. One thing to note is if you skip drive and you just like install this repo locally into Colab, you don't need to worry about this cell. So a lot of times what I'm doing is if I'm doing just inference or generating images and video and not doing a training session, I will skip the drive session and just install the repo locally. That way I always get the latest version and can play with it that way. So just a little tip there. Okay, so now I'm going to jump down to my projection notebook or my projection stuff, and I'm going to quickly download my pickle file. Okay, so there's my pickle file. So the top here is the basic projector. This will just be projector.py. I always recommend, if you've never used these scripts before, to use -- help afterward. If you run this cell, what you'll get is a bunch of options. And that'll sort of help you like know what's available in the model or in this particular script. So you'll see here I need a network, I need a target. My target is going to be an image. Number of steps, so we talked about how many iterations do we use. This says it defaults to 1000. Seed, so this is the seed. This is with the random seed we're going to start with, where we're going to start our model. And then there's save video, which means you can save out a video. And then where do you save all this in outdoor? So I'm actually going to skip, because we're running a little short on time, I'm going to skip the basic projector. But this is all of the stuff you would edit. So let me show you an example of this in my script. So you'll give it your network pickle file. So in this case, I would use this. Oops, that is not the right pickle file. 1 second here. Let me find the right one. That's for my other demo. We'll talk about this when we get to that other notebook. But if you see a .pt file, well, we made .pts last week, right, as a part of feature vectors. There's also versions of people's StyleGAN models that use this .pt. But for this version, we need the pickle file. All right, there we go. Oops, wrong one. So for this, we would edit our network file to be our pickle file. And then you've got where do you save all the images and video. Your target image, which is the image you're going to upload. So I actually have an image here. Okay, let's try this. Upload. So this is the image. I found it off Etsy. So this is the image that we're going to use for this. So I'll just upload this. So that's what the image looks like. We saw it earlier. So you would set your target to be this. And then you set the number of steps as well as the seed. So again, the seed matches all the other seed variables, right? So maybe you've exported a bunch of these through interpolation or just generating images, and you say maybe like, oh, I like this one because it looks closest to what I'm shooting for. Maybe there's some pink flowers or some green flowers in there, so you want to set this variable. If you don't, it's not really the end of the world because as I showed, using those using those projection methods, it moves pretty far away from there. So this is negligent in terms of like updating it, but you can set this and see if it does change your output much. So I'm not going to run this just because I want to just jump down to the Peter Bailey's one and talk about that one. Also, for this demo, I'm going to run these in much shorter steps than I would normally do because it does take about 5 to 10 minutes to generate 1,000 steps, and I don't really want to sit here and wait for that. So just know that I'm setting these to a lower value, but I would definitely recommend shooting for starting with about 1,000 and maybe going up or down depending on that there. So down here is the Peter Bailey's projector. So again, if we run the -- help command from here, you'll see we've got way more options. Network, same as before. Now it's called target image, and that's because this projector could use clip, which means there's both a target image and a target text. So just be aware that the difference between this one and that one is the target image. Initial latent is if you actually have a W vector file, you want to feed it, you can use that. Here's the learning rate, and here you'll see the default is 0.1. Number of steps, so again, it defaults to 1,000. Seed is an integer, so basically if you have a latent image or a latent vector file, you'll want to use that over seed. Say video, outdoor, and then a bunch of what is called use dash, and these are the loss options. So use VG is the default. If you say I don't want to use VGG, you pretty much have to then also, you do have to use clip, right? So these are the sort of the two big ones. The rest of these are sort of modifiers on top of what exists. I guess you could probably use pixel loss by itself, but it'd be pretty bad. So you pretty much have to use either VGG or clip. Then we've got those pixel values, the penalty value, the center value, and k-means. So k-means is a way for clustering. This is again what Dusk was referring to, which is like, how do we pick our best location to start with? I believe right now k-means only works with clip. And also I should say, like, this notebook isn't really set up to use clip. If you're interested in it, I'd be happy to show you in like a co-working session over Slack, because you kind of have to break some of the PyTorch stuff in here to get clip working. So I turned it off for this. So I would definitely recommend to start with, don't use clip. Just try using VGG and some of these other values. And then there's other notebooks I have that'll use clip. But you could come back to this and maybe figure out how to make them work together, or I can show you later. So this is everything that's available in the Peter Bailey's notebook. So we'll go ahead and just walk through. We'll do one of these. And you also see, like, what's helpful to know is what the defaults are here. So you'll see what is by default turned on. I believe pretty much everything is turned on by default. So you may want to turn some of that off based on what we've already looked at. So you'll update your network file to be a pickle, your pickle file. And then we'll set the out direction to this. So I'm going to set this to projector P. Bailey's. Target image. So when I set my target image to this image, I'm going to set my number of steps really low just so that we can quickly see what happens here. But this will not be a good looking image, just FYI. I, by default, usually turn off clip. Again, it doesn't really work here. You'll have to mess around with it a little bit, or I can help get it set up for you. But for now, I'd probably start without it. So we're just going to use all of these. And then as I showed, it probably is better if we turn off center. So we're going to do use center equals false. One thing I definitely recommend you do is, as you play with this, maybe name your folders so that you know what you're looking at. So I'm going to say no center. Just that way I like sort of know what I'm actually generating with these images. And lastly is my seed. So I looked at it with 10, and we'll set this to 10. So at this point, I can just go ahead and run the cell. This will take just a minute to get set up because it has to load in all that other stuff, these like plugins and whatnot. While this runs, any questions about this particular code? Cool. All right, so once we've got our plugin set up, you'll see that these score very, very quickly. But if you were to do this for 1,000, it would take a little bit longer, 5 or 10 minutes to do 1,000. So what you're getting here is you're getting a distance score. A distance score is essentially like how far away are these two images, and then a loss score. And ideally, both these go down. So you will see that like at some point the distance score seems to go up. The loss score seems to always more or less go down, but the distance score can kind of fluctuate a little bit. So obviously, if I were to run these for much longer, you would see both these scores go down quite a lot. When this is finished, wherever your output file is, you will get both a video. So this is a video this is that like Harrison Ford video I showed where you see it sort of slowly move in the right direction. You'll get the image, which is proj.png. That's going to be the image that it outputs. You'll get the target. This is again like just so you can sort of see what the target was supposed to look like. And then you'll get this file projected_w.mpz. This is actually what the vector is. So this is the vector in W plus space essentially. So and maybe after our break, I'll show you how to if you were to generate multiple of these, how to combine them. So just know that in your folder, these things will be here. They will all be named very generically. So again, for your own sanity, you might want to either rename them before downloading them, or once you download them, rename them, because otherwise you will end up like me, and you will have 15 proj.pngs, and you won't know what any of them do. So don't be like me, basically. So here's what this image looked like after 50 iterations. It doesn't look good. This one, it was after 1,000, right? So clearly this needs to run for a lot longer. I could maybe play with the learning rate, which would be, you could anywhere in here, --lr equals, maybe I want to make it higher, 0.2 or 0.15. I definitely recommend moving in small increments with the learning rate. If you crank it up too much, it's just going to feel like chaos, I guess is maybe cool, but for the most part, you'll want to just play with these a little bit. So 0.1, maybe you want to go down a little bit and go to 0.07, that sort of thing. So this is sort of like the process of doing projection, and then you're going to play with it. You're going to play with it a lot more. I would say once you have found a couple images that work well, you might want to just jot down what your settings were, because I find with most models, your settings will generally stay the same on a per model basis. So if you've got 3 different models, you might want to move stuff around a little bit to see what works best. But if you're sticking within the same model and sort of similar images, you might find that just sort of the same settings are generally worthwhile and sticking with those. Any other questions? All right, so why don't we do this? Why don't we take an 8-minute break? So we'll come back at 35 after, and we'll look at, we'll look at how to combine these using a script that's right below here, which is combining all these MPZs together. And then we will look at a bunch of clip models. Cool. So I'll see everyone now in 7 minutes. All right. Hey, everybody. So I'm going to go and just, actually, before I jump into the combining Ws, were there any questions over the break? No? Okay, cool. So really quickly, let's take a look at how to combine these. So just below the projection code in this notebook, you'll see there is a section that is entitled Combine NPZ files together. So the way that the generator, if you're doing interpolation, it's going to expect multiple W files sort of combined. So you have to sort of combine them in a script first and then use that. So the script I have here is this combine npz.py file, which you'll see is I've just dragged in a bunch of NPZ files. So when you have multiple NPZ files, either in multiple folders or whatever, all you'll do is you'll just take the path from each one of those. And in this NPZ's argument, you'll just put each one of them in a sort of in a string. So put them in a string with commas separating them. So once you add all those together, you can then run this script. And what you'll see is it runs very quickly. It'll take all of these directions or all these vector files and it'll combine them. And it'll spit out sort of what the size at the end. So you'll see here there are 3. So there are 3 vectors, each of 18 stacks or 18 channels by 512. So now we've combined them all. So each one of them is a point. One thing I should note is that order matters here. So if you are looking at these and you know you want this particular vector to be the first one and this one to be the second one, the order that you stick these in matters, because as we will take this file and use it in generate, it's going to assume the order in which it finds these vectors is the order in which you want them to like animated. So just keep that in mind here. So for generating, all you're going to do then is you are going to, just like you would any interpolation script, you use the process of interpolation. You can define your interpolation method, although I believe it probably has to be linear for this. Space, it's really important that your space be W here. If you set to Z, it's probably not going to work. And then point to your network file, so your pickle file there. Where are you going to stick it? Your proj interpolate folder. And then the last thing is you're usually probably used to setting these as seeds, right? Where it says seeds equals 0, 3, 10. Instead, what you want to use is projected-w, and then you want to give it the path to that combined file. So see it combine the files in this folder, content npz combined. So make sure that you pass at this path. And then you also do want to set like if your frames count. So I'm going to make this really short. I'm going to make it 20 frames per step. And I'm just going to run this really quickly. Oh, and one other thing to know is that if you want this to loop, you always want to set your first vector as your last vector. So I didn't do that here, so this won't loop. But again, this is sort of like, you can think about these as the seeds. You're sort of combining them into a single file and then running them from here. So my video is output. Where did it go? Proj interpolate, download. And there you go. That's really fast. Let me just open this and we can scrub through it. But you'll see we now interpolate between each of those points. So this is really cool because you could project a bunch of images. Like I've used this previously where I have projected something like, famous celebrities into FHQ and then been able to interpolate between, I think it was like Jennifer Aniston, Bruce Willis, and other people, right? So like you can do fun things with this now that you've got these like tools to combine. So I definitely recommend playing with that. But that's just how you combine all of your found or your discovered vectors together to then interpolate. Any questions?
If I want to change the ease, where do I change that?
Yes, that's in the easing method, or I think there's a argument here. Like if we just use generate.py -- help, there is easing right here. And these are the options I've built in so far. I will probably eventually add to this as requests come in. So if there's a method here you want that doesn't exist, just let me know, and it's pretty easy to add. But yeah, these are the easing methods that I currently support, but there's probably, there's obviously millions more. So yeah, you just use the easing there. So I think the video I did, does something like, it's probably circular ease out or circular ease out 2. Actually, you know what? It's probably ease in out quad. It has that sort of like, it sort of like slows down and pauses at that potential point and then speeds out of it. So that's probably what I used.
Can you use those points from different models? Does that make sense?
Not really, because again, they're just sort of numbers in a model space. So like you can't really go from like one model to another model. I guess you could, but it would get very complicated. It would be like you have to do some like blending stuff that I've seen people do, but it's like very annoying to get set up and running. So I would say for this method, or like what's here, it assumes it's all the same model. Cool. Other questions? All right, let's take a look at clip. So I just want to make sure I've already got a couple. Because clip takes forever to install, I've just gone ahead and pre-installed these in my notebook, and I want to make sure I didn't get any errors there. Cool. Okay. So we have now looked at how to do this in projection. Adam had requested that we look at how to do this with clip. I dug around through a bunch of notebooks, and I have a cursory knowledge of how many of them work. This is definitely not going to cover everything, but I can sort of tell you what notebooks I've personally found are good and which ones are not. So the idea here is like, what if we could just feed a piece of text into our model and we would get an image out that looked like that, right? The truth is it's not that easy, or it's like in some ways it's easy, but in other ways it's very hard. So here are a list of, this will obviously be in the slides that I shared. Here are a list of maybe 5 notebooks that use Clip or could use Clip. All of them have different approaches and all of them have slightly different return on usage. So I would definitely recommend the 2 that I've asterisked here are the ones that I'm going to quickly run through in our notebook or in this class. I can do that in 45 minutes. Yeah, that'll work. So I'll run through these 2. The cluster search is what I describe as spray and pray. I'll talk about what that means in a second. But it's fine, but it has some challenges. The Peter Bailey's one that I showed you will probably actually work very well, but I really need to get it set up so that it works with Clip. So I will probably try to do that this week, is I'll just set up a separate notebook to do that so you can run Clip with it. I actually bet that this would work fairly well. I think Clip plus those other loss styles that we looked at, I think this would generate some pretty interesting stuff. Plus you could do image plus Clip plus these other things and have like a really pretty finite tool. So I think this would actually be good. I'll probably do that and then maybe record a video on how to use them all together if you want. There's a notebook from Clip Approach, which is from a person whose work I always follow on Twitter. I assume it's Lars, L4RZ. They do a lot of really interesting work with various things and do a lot of good research into their tools. So this is one of their notebooks. He reached out to me today and said that he's got updates that he's going to try to push in the next week or 2. So there might even be a new one that's even better. I found this one kind of fun to use, but it's kind of limited in some ways. Style Clip. So this is a fairly big research project that a lab, including some folks at Adobe, just put out maybe about a month ago. I've actually found this works very, very well, which I initially kind of struggled with, and I have some thoughts on why that is. We'll definitely look at this one, but I think this one could work pretty well for pretty much everybody's models. I have an assumption that somewhere they decided that they were going to use a face detector and then they turned it off. So if you, I would also recommend, I'll link to this. I actually already did link to this in our class notes. The paper for this article or the paper for this model is fairly readable. It kind of describes how the process they made different versions of this. So you might find some value in that. We'll look at this one at the end of class as well. And lastly is a model called StyleGAN, which I think is just kind of a fun name. But it also, what it uses is it uses Clip plus a face segmentation model. So if you've never seen segmentations, it sort of like says, here's the nose, here's hair, here's the cheeks, here's the mouth, and here's the forehead. So it uses like a loss score using a face segmentation model, where like you can target Clip to like make the lips bigger, and it knows where lips are on a face model. The challenge here is that this will only work for face models. So like if you have a non-face model, it's going to be really frustrating to use. So I've linked to it, but it probably won't work for most of our models. But I think it's interesting. I think we'll probably see more and more and more of these approaches because Clip is far easier to use than feature vectors, right? We looked at it last week and it was like, oh my God, we have to look through so many of these things. It's very likely that Clip will sort of obfuscate the need for feature vectors in most cases. But now it's like, how do we control the actual output while also controlling Clip? So yeah, so we'll go through 2 of these, but I definitely recommend just maybe if you've got time or really interested in this topic, playing with some of these. So there are some challenges with StyleGAN and Clip. The first that I would say is you probably have seen Clip with other models, like other generators, like VQGAN or BigGAN or Siren. And you might say like, well, why can't I generate images like that using my StyleGAN model? And the problem with this is that VQGAN, BigGAN, these other generative models are trained on massive data sets, right? They're trained on ImageNet or trained on other things. Whereas StyleGAN is trained on a pretty fixed set of data. So you can't use Clip and say like, draw me a house on the beach with a dog playing fetch in the front yard and expect FFHQ to know how to draw that, right? So if you've seen other Clip generators, you're probably like, oh, I should be able to use StyleGAN with that. And within limits, you can, right? So within Clip, you could say, show me a face that has green eyes, black hair, and bright red makeup or bright red lipstick. because that's in the data set, because that's in the model, it can do that. But if you're asking for things outside of it, like it'd be interesting maybe to ask for Mario with Clip, because I don't know that it would find Mario in the same way that the projector did. But I think that'd be a cool project. It may be kind of fun to see the differences there. So a lot of this stuff actually has to exist in your data set. So I actually tried something this week that led to some bad results, which is I tried to find a face of a person wearing red glasses, and the problem is I don't think many people in FHQ have red glasses, right? So again, it's like a little bit of like what's actually in your model. Can it find that? Clip is very smart. StyleGAN is generally very narrow. The reason people use StyleGAN over, say, like one other, yeah, exactly. There's only one Sally, Jesse, Raphael. StyleGAN is trained on a very narrow set of data so that it produces higher quality, higher resolution images. Whereas stuff like VQGAN or other things are trained on a wider data set, but they generate smaller images at lower quality. So that's sort of your trade-off there, which is why lots of people use those other models to generate clip stuff. I will say there are many tools that use what I describe as spray and pray. That very first model uses a thing where basically it just generates a shit ton of images and then it scores them, right? So it generates 10,000 images of women with glasses, or female presenting faces with glasses, and it just says like these are the closest ones. And if you do that, half the time it won't even show you people with glasses. It'll just show you people that look like they're women. And I guarantee almost none of them will have red glasses because it doesn't actually know how to generate red glasses. So this sort of spray and pray method, which is just like brute force scoring images, is good. I mean, it helps you know what's in your data set. It's probably better than like generating 10,000 images using the generate script and then going through the notebook and pulling them out one by one, right? So if you know you're looking for something specific, Clip might help you find it better. There are usually in these spray and pray there are some optimizations. They do a little bit of loss scoring, but I found that the way they do it is pretty bad, or like not particularly well crafted. So again, if you're looking for something that's pretty common in your data set, this method might work fine. If you're looking for something that is uncommon in your data set, this sort of method of just like brute force generating a bunch of images and scoring them probably won't. And as always with anything with Clipped, this idea of prompt engineering, which is a fancy word for saying change how you write your sentence, really matters. So how you say, there was actually a funny thing just today or yesterday that someone found if you add Unreal Engine to your Clip prompt, you get like much higher quality 3D rendered images because apparently Clip knows about Unreal Engine. Or like if you do RTX on or off, or like Blender or Cinema 4D, Clip knows what those images look like. So it'll generate more 3D style images. So this is a case where prompt engineering is really important. So you saying, give me an image with flowers, versus saying, give me a high quality photorealistic image with flowers are very different. So Clip's whole job is like, you have to really like, instead of tweaking the vectors a little bit, you're tweaking the text prompts. So it's, yeah, and say please, yes. So it's, this is a really, really important part of anything you do with Clip. Another thing I'll mention is that I believe you should definitely generate videos with all these tools. So I believe most of these tools will allow you to generate videos, which is like after every step of iteration, it creates a frame and then you can generate videos from all those stack frames. I think you'll notice, I've certainly noticed, especially in that style clip one, that I didn't need to run nearly as many iterations as I thought I did. And in fact, if you overrun too many iterations, you end up with a thing where it almost feels overbaked. It like feels kind of gross because it's just like been iterating over and over and over again, and it kind of gets like gross and noisy. I'll show you some examples of that. And just like with projection, I definitely recommend running it multiple times, because the more times you run it, you'll get different random results. And especially with Clip, because you're not projecting to an image and it's on image one-to-one, Clip will probably generate lots of different results. So yeah. The other thing to know with these models is, again, do you want to start with an individual vector? Like, do you want to start with a particular seed in mind? Or do you want to start with just say like grab a random one and try to influence that particular random image? So all these things come into play. So again, you'll see like the way we use projection and the way we use this are fairly similar, but slightly different. So this is my example of me trying to find a woman with red glasses. And you'll see what it did is all it did was make her eyes red. So, it understood kind of, but instead it made someone look high instead of like giving them red glasses. So, and it didn't even give them bloodshot enough eyes to really make them look high. It just gave her like a weird rash, I guess. So again, this is a case of where there's probably just not enough data in this model to really find this thing. Now I could have cranked up the iterations and seen if it done much more. I don't know. I quite honestly don't remember which version I used this with. It might have been one of the spray and pray like cluster models. So that probably also held me back a little bit. So who knows? Maybe you'll run this with StyleClip and find much better options than I did. Yeah. So again, there's lots of this stuff happening, and you'll kind of have to see like, okay, what does StyleGAN know and what does Clip know, and how do I like combine those two? So another thing that I recommend doing is actually think about Clip more as an editor and not as a like full-on generator, which means one of the first tool we'll look at is this StyleGAN approach notebook by Lars. And what you do there is you sort of set like, here's the image I have, and I want to edit the image to be different, right? So here's an image of someone, and I want them to have blue hair. Or here's an image of flowers, and instead of them being yellow, I want to make them red. Or instead of purple, I want to make them yellow. So that's probably a good way, at least for starters, to think about Clip, is not as like it'll generate the perfect image for me, but more it'll change the image I've already given it. So I would definitely recommend that. And then, as I said, I've generally found that the StyleClip and Lars notebooks are the most interesting results. My guess is that the Peter Bailey's one will also work really well, but your mileage may vary. So I definitely recommend if you find another notebook that you've never seen before, and if it looks legible or editable, like please feel free to try it. And if it works out, like drop a note in Slack and we'll all play with it and see how it works. So here's an example of this Lars notebook. So what I did here is here was my text prompt, a high quality image of yellow flowers. So we'll look at what this changes over. I believe this is again maybe 100 or 200 iterations. So let me pause this real quick. So where I started was at this point. So I had an image and I wanted yellow flowers in it, right? So I said, how do I take this image and get yellow flowers out of it? And what you'll see is that this particular notebook was not able to convert all of the flowers to yellow, but it is able to convert some of them to yellow. And in fact, I believe, yeah, right about here, maybe. Let's see. Somewhere along here, it actually it also made this stalk kind of yellowish. But as this trains for a while, you'll see it just sort of goes back and forth. And this might be an example where it's caught in one of those local minimas and maybe I should increase the learning rate. But it's also an example of where maybe this is the best it could do with this image. But I still think it's interesting because it was, again, we talked about entanglement last week with feature vectors. This is fairly disentangled. It was able to make this area yellow without really changing the rest of the image. And I think that's pretty interesting. I think that's a valuable tool. This would be, I would use this. I would try to use this more. If I were showing this to a client, they'd be like, can you make the flowers more yellow or more red, but not change the overall structure? I might try Clip to see what Clip can do. I also want to mention, let me dig through my thousands of generated images here and sort of see if I've got another one here. So I was talking to Lars about this and he said, crank up the learning rate. There's also some noise things you can edit. He said, just crank those up. So I did that. And here's what I got. So you'll see I got more yellow, but it did start to change the actual image a little bit. And this is one of the challenges. Here's another good one. This is one of the challenges with learning rates is that learning rates might get you a better result overall, but what if it makes your image really noisy? Or, what if it just changes too much of the image? So again, we have to think about entanglement. How much entanglement are we okay with? How much are we not? That sort of thing. So let's actually go ahead and just look at that notebook real quick. So this is what he calls it Clip approach. Oops, and I already have this open. It's this one. So this one uses the basic PyTorch model, so you can just load in pickles as is. So there's a lot of text here about how to use it. Make sure that, so in my case, I already installed PyTorch. This takes forever. Installing Clip always takes a long time. I don't know if it must be a big model or they're changing stuff. This can take a little bit of time. So I just jumped in and did that step already. So at the very top here, he has sort of what's your text prompt going to be? And then what seed do we want to start with? So what I went ahead and did is I generated a bunch of seeds before I did this notebook in my other notebook. And I decided that that image 2 or seed 2 is the one I wanted to play with. That's that purple flower with those stalks. And then auto seed, I believe, what does auto seed do? Oh, I think auto seed generates a random seed, whereas, or like it generates, it does that clustering where it tries to find a good starting image versus setting your seed value here. So if you were to set this to true, I believe it's going to override your seed value and just try to find a good starting seed. So in this case, I really want to edit this image, but I want to get more, let's say, of yellow flowers. Or actually, let's just say of red. Let's try to make that one red instead of yellow. So a high quality illustration of red flowers using this image. So when I edit this image to be this. So go ahead and run the cell just to save all these variables. Down here this is where you set some learning rates and some other things. So in this step, here's how many steps to run. I'm going to run this only for 200. This one runs pretty fast, but just in case. PSI is truncation. So I would assume like I've already run this at the same truncation value. So you probably don't want to mess with this once you've sort of decided what seed you want. Next is the initial learning rate. So here again, I would generally start with what they've suggested. So they suggested 0.04. What I generally do is if I want to go up, I'll double it. And if I want to go down, I'll have it. That's generally my approach to starting with those values, just so I sort of get a range, right? So you can double it, and then if it's still not feeling like it's jumping enough, you can like double it again. But I wouldn't like go 1.0. That's probably insane. So like I try to keep it somewhat similar to the range that they have here. And he also made a note here that said like he would originally start with 0.02. So for this, I'm just going to keep this as is, and we'll go from there. So I think I ran this cell already as well. Let's just see. I did. Yep. And then, so here's where you need to load in your pickle file. So I believe I'll just run this gdown. This is if you want to use FHQ or StyleGAN 2 cats. He's got all the code you need already here. I'm just going to skip this and bring in my own model. And then you need to actually assign the network pickle variable to your path. So let's just see where my path is. I believe this should be local or relative to your this folder. So you'll see I didn't do /content because it's actually in this folder. So I'm just going to run this and make sure this is saved. I realize now that I had additional notes here that I don't think made it in. So let me try to figure out where those notes went, and I'll update that tonight. So now that we've assigned this, we can skip this step. This step will actually just generate the image. So if you wanted to actually generate and make sure your image is what you expected it to be, you could set your value here and then just display it. I'm going to skip this because it'll just take a minute or two that I don't need to worry about. So we'll see, this is seed 2. So this is the image I'm going to edit. And then you'll need to install a bunch of code here. So you don't really need to edit anything in here. Just go ahead and run this cell just to get our code saved into Colab. And then we'll skip past this cell. And we'll come down to this. So this is where we run it. So it doesn't really matter what any of this says. This has already saved all your variables from above. Now there are ways, like I think one of the things he's gotten here is if you wanted to load in like a W vector, you could load it in here. If you wanted to, well, here we're going to save out. So here we're going to save out an MPZ file. So again, we're going to get our final vector from here. So one thing you could do is you could run this a bunch of times, save all your MPZ files somewhere else, and then bring them into the generate notebook, combine them using that script we saw, and then generate latent interpolation from these. So let's go ahead and just run this. Num steps is not defined. What did I do there? And I never ran the cell. So if you see an error like that, but you've seen these variables, oh my God, bug, shut up. Come on, shut up. Okay, so if you see these variables and you get an error message that says like, hey, I don't know what that is, probably means you didn't run the cell. So let's just run the cell. And then we'll come back down here. And we'll run this, and it should run for us. because we have a new notebook, all these plugins always take a little bit of time to get running. Cool. So here again, you'll see that we have a loss score and we have what's called a proximity score. I believe the proximity score is similar to distance. So ideally we see the loss score go down and the proximity score go up. That means that we are reaching, our loss is going down and we're getting closer to the image score that we want. And we have a negative loss score, which maybe means we're calculating our scores weird, and or maybe we're overshooting. I don't know. We'll have to sort of download it and see what we get. Cool. All right, so that is going to save out a bunch of images. So there's an out image as well as our MPZ files. So let's go ahead and download this. So there was our image, and I mean, it's done an okay job of making our images more red. I wouldn't say it's done a great job of it. So this again is a case where maybe I want to tweak my text prompt. Maybe I want to choose a slightly different image. That image did already have a little bit of red in it, so I feel like it could have already just said like, I already see what I need here. It didn't really do much. Now there's also down here, one thing I'm noticing is it didn't actually save out multiple images for me. Is that right? Let me see if this is going to throw an error. Yeah, okay, it didn't find any images or any video. Wonder if I didn't turn on the video setting up here. Let's see. Oh, here's what happened. So there is a variable here called save video. I recommend setting this to true, especially for your first couple runs, because you want to know how many iterations is a good amount of iterations. So for example, I believe, let's see, was it this video? Nope, it was this video. So this was my first video. And what you'll see here is, I believe this again was like 200 iterations. You'll see that for the last third of this, nothing really changed. So I could have made my iteration count much lower, like maybe around 25 or 50. So I would definitely recommend turning on this save video to true before running this whole model. Like if I run this again, it'll update it with a video and we'll get video outputs. One other note is if you have a lot of iterations, like if you're doing like 1,000 iterations and you try to run this last cell, it might crash your notebook because the thing is displaying video in Colab is a nightmare. It's trying to display a really long video in Colab and it will probably crash Colab, in which case you'll just reconnect and it'll be there and you'll be able to download the video. So if you do run into that error, I ran into this error many times last night. So just be aware that what you might really just want to do is just like get the video file from here. So that's this notebook. So I find this notebook really good for fine-tune changing, so changing a little bit of images here or there, or editing an image. So again, maybe turning someone's hair blue or changing a flower to a different color. I find that this can work pretty well, especially if you play with these values here. And I also I kind of want to reformat the way this notebook is set up because you do a lot of up and down scrolling. So I might do that this weekend. We'll see. If anyone is really frustrated with this notebook after trying it, I can tweak it a little bit so it's a little bit easier to edit and whatnot. But that's this notebook. Any questions? Okay, so the other notebook I'm going to show is StyleClip. And initially I was kind of hesitant about this notebook, but I actually really like it now. I was initially hesitant because the code for it's just a little janky. Like whoever wrote it, like they're definitely researchers and not like developers, which won't bother you. It bothered me trying to figure out what was going on with it. But I think I've set up the notebook, so it's pretty efficient. So style clip, again, it just sort of takes text and it can find the closest images to it. And again, there's sort of a edit method, or there's like just a like find me a random image that matches my needs and then optimize for it. So this is an example of where I fed style clip a text of a high quality image of yellow flowers. And so what you'll see here is that very quickly, it started with this image, right? And it was very quick to sort of optimize toward a really good point. And then it kept going. And this is a case where you might want to like think about how many iterations you run. Again, as this ran for more and more iterations, it got kind of uglier and uglier. So this might be a case of where one, you might want to save out all your images like as a video, but get them as individual frames. So then you can pull out your favorite image and just use that. Like this one's pretty good. Maybe back up a little bit. Like that one's pretty good in terms of quality. I believe you can also, from this notebook, I have to look in to see how you can how to tweak that. I believe you can also dump every single W vector as well. So it'll be like, frame 1, frame 2, frame 3, frame 1 vector, frame 2 vector, frame 3 vector. So that might be a good way to just get the best vector out of this. Or, run it again, but set your iterations to be lower. So that's sort of a cool thing about this notebook, is you can sort of play with the iterations of this. So obviously, like, I have yellow flowers in my data set, so like that wasn't too surprising that I was able to do this. So I want to try something a little bit more out there with Clip. So I did a high quality image of multiple flowers in the style of Andy Warhol, right? So you might have seen his like screen print images. So here's what this one came up with. So this is only 50 iterations. And while it's not perfect, you can almost see what it's looking for, right? The colors are starting to get more flattened, that screen print look, like maybe some solarized edges types of things. So it did a pretty decent job. Again, maybe I would stop it a little bit earlier because it does kind of get a little bit gnarly again. And then I did one that was also 200 iterations. And so you'll see here, like this almost happened on the same starting point, but they ended in very different places. And I don't really like where this one ended. I think I much prefer the first one. One thing you'll also notice is that this is probably a problem with my model in particular, but as this runs longer and longer, right? So if I'm here, like this looks pretty good. I could probably use this. But as it runs longer and longer, it gets this really like hazy, like nastiness to it. This is a case of where if you overcook something, doing too many iterations, it probably won't happen to everyone's models, but my model in particular like had this really big issue of just like, it's trying to optimize all these little pixels around it, which just doesn't look good. So this is a case of where, again, I would probably run this a couple times and just realize like, you know what, like 25 iterations is good for me, or 50 iterations is good for me. So just be aware of that. Again, it will probably be different for everyone's models, which is kind of one of the frustrating parts of this. But just be aware that you can kind of play with these things and sort of see what happens. So, in a world where we hope that these models give us great results in like 10 minutes or less, I find that we always end up spending 10 hours or less optimizing these. So just, again, know that you're going to spend a little bit of time to play with these. But my guess is that also like on a per model basis, you will generally find that like a certain amount of iterations works well for each model. Like you might have one model where it's like, oh, if I know I'm like putting this type of image into this model, it's going to take this many iterations. Or if I'm doing this and this, it's going to take this many iterations. So you might find more commonalities within your model as you play with these things in each set. So that is the Style Clip notebook. So we'll quickly look at how to use that here. So this one will open as Style Clip Playground. Style Clip has a bunch of different notebooks. I haven't gotten to all of them. This is the most basic one, which just does clip guidance. But I do find it's like pretty cool and like fairly good at what it does. So we'll just run this real quick. Looks like I already have. I wonder if this is still open from like earlier today. Okay, well, let's find out. It looks like all this stuff has already been installed. You'll run this code. This code takes a little bit of time to run, so make sure that you give yourself some time here. And then, again, I'm going to skip opening Drive because it just is a whole other process. I've already downloaded my file. Oh, so one note about this particular model. We'll talk about this a lot more next week. This requires a slightly different format of model file. It's going to use a model file in the .pt format instead of the .pkl format. The reason for that is there is this thing called, and you might hear, as you get more interested in StyleGAN, you might hear about the Rosinality StyleGAN model. Rosinality is someone, it's like his life is just rebuilding projects from papers, sort of like his hobby. So Rosinality was a PyTorch version of StyleGAN that this person started building 2 or 3 years ago. And because most researchers prefer PyTorch to TensorFlow, everyone got really excited about this version and just built off this version. So lots of people, when they say they're using StyleGAN, are actually talking about Rosinality. I have a notebook here. We'll cover this more next week because a lot of the audio reactive stuff we're going to look at is also using Rosinality. There's a notebook here that will allow you to convert your model to a PT model in like 2 or 3 clicks. I probably already have a recording of this, but I might do another recording with this version. So for you, you'll need to convert your .pickle file into a .pt file using this notebook. Then you'll save it to Drive or somewhere else, and you'll bring it into this notebook. So that's the one key thing to be aware of is you can't use the .pickle files here. So once you have your file here, what you'll do is this is another sort of editable thing where there are 2 experiment types. One is called edit and one is called free generation. You can probably guess what this means. Edit means you are going to set your latent path. So this actually means what you're going to do is you need to save out a vector file, which is why I don't really do it with this because it's annoying or like I don't do it very often. So if you save out a vector file like a .npz and you paste that path in here, you can edit from that image. For this model, I'm just going to do free generation. It works fine. So basically it's going to give me a random vector and then start from there. You will need to give the path to your .pt file, which goes here, and then your description. So here we go, high quality image of a field of wildflowers. This one turned out to be really bad for me. It did not work well, so I'm going to change this. So a high quality image of, let's just say red flowers. Again, how you edit this is probably going to matter, right? This is where I could do, is it an Andy Warhol style image? Is it a high quality image of red flowers in the style of Andy Warhol? Like how you phrase that matters. It's kind of annoying, but that is true. So just think about that. Optimization steps. So as I showed, it seemed like I don't really need that many. So I'm just going to set this to 25. L2 lambda, I'm not entirely sure what that is. I need to read through the paper. I left it at whatever value they already had. My guess is, since this says L2, my guess is some sort of penalty score. That's usually what L2 usually stands for, like type of loss or like type of distance score. So that's what L2 lambda is. And then create video. I recommend leaving that on just so you can sort of see how it goes and seeing if you want to change either your learning rate, which is set here, or if you want to change like how many iterations you're doing. So this is the main cell that I recommend running. They have this other cell where they weren't allowing anyone to edit it. I've made it editable so you can play with it. So you will see that their learning rate starts at 0.1. So if you want to change some of these things, you can sort of see how it goes. There's also this ramp up score, which I assume is some sort of decay, and or maybe it actually gets stronger over time. I don't know. So anyway, you might want to play with this value too. I also noted in here that the default was 0.1. So if you change it lower, you can always remember to go what to go back to. So save this out as well. And then this one's fairly easy. The only cells you need to run are these 3. So once you've installed all this code above here, you just edit this one, and then this one is actually going to generate your images. So we'll go ahead and run this. Why did that error out? got a folder right there. And I even have an image like that. Oh, I see what happened here. This is one of these gnarly issues where if you... So what happened is I must have opened this notebook and it was already running a different tab, and then I reinstalled StyleClip twice. So all I need to do here is just go to cd .. and that's just going to put me in the right folder. This happens quite frequently, so just be aware of, like, usually when I get error messages about paths not working, I always do pwd just to see where I am. In that case, you saw it was like saying I was in a folder that was not in, or that it shouldn't have been in. So ideally I would delete this, but it's kind of annoying to delete stuff on Colab. So I'm just going to be in the right folder now. So now let's run this again and see if this works. Hopefully you will not run into that issue if you install this in the order that it says to and aren't doing any dumb stuff like having 20 different notebooks open in 20 different tabs like me. So now this is running. So here again, you'll see sort of a loss score as this generates. So you'll see my loss score is going down. This one doesn't surface the proximity score, so that's kind of an issue. Also, I'm realizing I might have been a little bit of a liar when I said saving. I don't think this one saves out z's. That's okay. I'll edit this one to save out our vectors so we can have access to them. It's non-trivial to do that, so I'll go ahead and do that. I'll make a note for myself in the chat to add that feature. Okay. So this one has now run. We're finished. This cell down here, when you hit play, it'll just like display the image that is turned into. There's my red flowers. So you'll see here again, I wonder if I want less iterations so that I don't get this red blown out background. This also may be a case of where using this where it says the free generation, it's probably generating an image that is already very red, and it might be over optimizing for red. So that's a case where creating my video or downloading my video is probably going to be a good sign of me seeing how that worked. Yes. I will say this notebook also does some stuff that I believe is supposed to make it feel user-friendly, but it actually doesn't feel user-friendly. It tries to like auto-download your stuff or like always save out the same file. So if you run this multiple times, you may find this a little annoying, in which case let me know and I'll edit this thing so it's less annoying. Yeah, so see, it tries to like download it from the console, which is fine. I tend to find that a little bit annoying.
I have a quick question while we're waiting for this.
Yeah, go for it.
It seems that one of the things we're trying to predict is how many iterations we're going to need. Is there any, has anyone looked into like gauging the change in loss and maybe when the loss stops increasing, just, stop iterating at that point?
Yeah, that's a good question. I would say just looking at my own loss scores here. See, it started at 0.7. Yeah, so maybe that's a case of like where it drops here. Maybe that is a good point. Yeah. My guess is that just like maybe people haven't looked at that enough, like in a detailed way to sort of say for sure. But it's certainly possible that that's what the deal is. So let's just see. So I'm just going to open this and we'll scrub through it slowly. So it seems to start with the same image. So there must just, maybe it's just like picking a random vector or like a random seed vector and starting there. But you'll see I get to red very quickly. So again, it's like I really should be doing it from about here. So that's probably maybe 20 steps at most. So yeah, again, it's like this one does, oh, also this is, because I'm running this multiple times and I changed my step count, this is actually the whole video, and then it like found old frames. So again, they should probably make this more user-friendly or less user-friendly, one of the two. Instead, it's in this weird middle state. So again, here I'm like sort of like, well, maybe it's just because it's red. Maybe if I change it to blue, it would need a longer time or less time or whatever. So it's a little bit of just like, what I would probably do with this is I would instead just dump out all of the states, like all the images and all the vector states, and then just pick the one I wanted and just use that. But you could see this as a way to like, essentially this is doing feature vectors, right? Like you could say, well, actually I just want to animate from one state to another, and then maybe go back or whatever it is. So you could sort of do that without ever touching the vectors themselves, like by just like sort of like animating this section. I mean, that's one way to use it, but it probably wouldn't be the way that I would go about using it. So I might edit this a little bit over the weekend. Sorry, I was doing so much research into clip stuff and had like 30 notebooks open, and then I was like, oh shit, I'm running out of time to do this for class. So I may come back and edit some of these because I do think they're really interesting tools, and I would just maybe build them a little bit differently for my own workflow. So that is style clip. So I definitely recommend playing with it. Again, you can come back up here and edit your description, and maybe you'll get a different result. Like I could say a high quality image of red flowers on a black background. Maybe that would be a way to keep it, keep that background black. This also is a case of where what Grant was showing us in like maybe, what was it, week 2 or week 3, where you might even want to have some negative vectors. This particular notebook kind of hides the code, but maybe we want like a positive vector, like do more of this, and then another vector that says do less of this, like less noise or less red backgrounds, like that sort of thing. And maybe we could combine those to sort of generate our clip images as well. So I think there's, again, lots of opportunities here. Clip came out in January or December or February of this year. So we've had like 4 months of people iterating on these things. I think we'll have way more stuff by the end of this year. As all of you know, with classes you've taken with me, like stuff moves so fast. Every class we're teaching a new thing because there's new tools out all the time. So there might be new versions of this that really like get even better. Like I feel like the Unreal Engine trick that people learned literally yesterday is also another thing that people will start playing with and finding new things about. Like, I don't know. I doubt StyleGAN knows about Unreal Engine unless you're training it on Unreal Engine images. But there might be other tricks particular to your model that clip can know or would work with.
It really helped. It helped a lot of times to tell clip not to generate anime. That's exactly what you're going for. It'll put anime base everywhere.
I was trying to think about, there was something that I did earlier where I was trying to generate something, and I realized it just like had the wrong effect on my images. I forget exactly what it was, but yeah, you have to be kind of careful about exactly what you put in here. With StyleGAN, it's a little bit less of an issue. With those other more general generative models like VQGAN or BigGAN, you will definitely get lots of errant stuff. You'll have to say like no anime or no nude women, those sort of things, because all that stuff is in these data sets. At least with StyleGAN, it's a little bit more structured to what is in your data because you've trained it, or like you know what it's been trained on. Cool. So that's it for this week. I've got a couple minutes for questions or other thoughts, questions, concerns, things we can talk about.
So I had this thought where I was thinking like the Lars notebook that you showed like had like some pretty good isolation, at least in some of the examples. And I don't know, I was thinking like, oh, maybe a technique for generating like general feature vectors would be to like run it on a bunch of images and then like average the difference in like the change of the vector. Is that worth even trying? I don't know.
Oh, I think that would definitely be interesting to try. I can imagine it would work. I mean, I think the challenge will always be, how do you make sure that the feature vector is generalized enough to like every image in your data set, right? Like this is what we saw with feature vectors too, right? You saw it in yours, which is like, if you do a feature vector across 20 different seeds, do they all do the same thing? If they generally all do the same thing, that's a good sign for a feature vector. But I would also wonder, would clip do the same thing across every seed value? Maybe, maybe not. But I think it's worth exploring for sure. The idea of just like, well, okay, if I want a blue to red vector, can I have clip generate all my blues and all my reds, and then can I take those vectors and sort of figure out what the, essentially what the, I guess it would be, God, I'm blanking on the term, perpendicular line would be, right? Like that's sort of how we would want to define it. But yeah, I mean, it's worth trying and seeing if that works. I don't know if anyone's actually tried that. So I will say the style clip paper, which I said I added the link to in the notes, there's two other versions of their sort of model exploration that they do. One includes some training, and one includes something, it's like training, but something else. So like there's lots of other techniques that they're exploring. I wrapped my head around it a little bit, but I was like, I don't really have time to like deal with another training setup. They also talk a lot about inversion, which is like basically projection. Like they say, project all these images in and then make sure that they work according to clip, and then like score based on the projected image as well as that data. So I think there's a lot of things that people could explore more, right? I guess what they're saying is that if you project a bunch of images in with people with blue hair, you can use that score and the clip score to like combine them and then find an actual feature vector, I guess is what they're saying. There's a lot of interesting stuff in their notebook or in their paper. I found their code to be very squirrely and like mixing PyTorch and TensorFlow together, which is like a no-no. So I don't know how accurate it is to what their actual like design was. Other questions? Okay, so the other thing I would say is for homework, I think it'd be really fun just to try a couple different projections, right? Like you can just use that Peter Bailey's notebook and just give it an image and give it your model, or give it a model that already exists, right? Like try to find Luigi in FHQ, or try to find an anime character in FHQ, because I think then you'll also sort of see like where these models fail and where they do work well. And maybe tweaking those variables a little bit to see if you can get better results or that sort of thing out of those is going to be helpful. I'll also mention next week we're going to look at audio reactive stuff. So I would maybe think about finding a short audio piece. Obviously, I don't think following along in this class is super helpful, but you might want to start to think about like, how would you change a model based on different sound quality, like what's baseline, tempo, those sort of things. So obviously you don't need an audio piece for class next Wednesday, but I might start thinking about, what sort of thing would I want to play with.
On the machine learning tip too, it might be interesting looking at Splitter. I think there's another model too that allows you to split an audio track into its component instrumentals of it. So and then you could that'll open the gates to all sorts of experimenting on an audio reactive.
Yeah, I have a
play with
I have a notebook that is Demux, which is it's like Splitter, but it's a little bit newer, and it's from, I mean, good or bad, it's from the Facebook AI Labs. I'll drop that in my notes so that if someone wants to play with that. The idea is it's what's called source separation. The idea is that you feed it a piece of audio that is like a band playing, and it can separate out the drums, bass, guitar, vocals from each other. To varying degrees, like all things machine learning, to various degrees of success. But yeah, you can play with that too. And one of the things that Hans, who makes the notebook that we're going to look at a lot next week, recommends is actually like doing that process, and then you can take those individual lines and use those to change various components of the model itself, right?
Yeah,
so you can take the drums and have the drums just affect sort of what's called noise, which like would maybe make it look like it's spiking, and then have the use the melody to just move the latent vectors, that sort of thing. So there's lots of stuff. We'll look at some of that next week. I don't think we'll get to cover all of it, but I might do a little bit of a Demux demo real quick, or at least I'll record it and share it with everyone so they can go ahead and play with it. But yeah, that's a great point.
There's also Jukebox, which is incredibly cool, where you can post a snippet of audio and it'll continue writing the song for you.
Yeah, I'm going to make a note here, add Demux. There's a really good person on YouTube who's also like in various channels. Yeah, I was thinking Johannes was who I was thinking about.
Oh yeah. He's on that.
Okay. Yeah. So I'll link to a video of his that shows how to use Jukebox, which is also like a cool machine learning model for audio. So yeah, we definitely won't get to cover that in this class, but I'll link to it in the notes if anyone's interested in playing with it. Because again, it's sort of like fun to generate machine learning audio and then do machine learning video with it. So
Yeah, I just mentioned it because we're getting into audio reactive stuff, and so we can kind of dovetail pretty nice. But it's not StyleGAN related, to be clear.
yeah, and just like there's only so many hours in the in the week that we can demo this stuff, but I'll link out to those tools if you're really interested in those. All right. So with that, I think we'll call it a night. Again, hopefully you guys get to make some cool stuff, and please drop anything or everything in the Slack channel. Again, even if you're like still in making dataset world, like please feel free to share that stuff. Like you don't have to feel like you're only sharing stuff from this week every week. Like please share whatever you're working on, and people can chime in and either like give you direction or like just give you a thumbs up and say it looks cool. So don't feel like it has to be related to exactly what we're looking at this week. All right. Cool. And then again, Saturday and Monday for co-working sessions if you want to show up for one of those. And again, doesn't have to be anything related to this. If you just have like, I have an idea for a project, how do I do this? I'm happy to talk about that as well. All right.
Thank you very much.
All right. Thanks, everybody. See you next week.
Happy Pride.